Action. So if you're a visual learner like myself, this video may be for you. Specifically, in today's video, I'm going to be talking about voltage drop that occurs when various different amperage loads are applied on different size wire gauges. So we've got all types of wire gauges available to us, and trying to choose the right one for different types of loads is really a critical step that you need to get right when you're doing different types of builds with DC electrical. So maybe some scene lighting or some fog lighting for your truck, for your rig, for your camper. Maybe a small inverter if you're looking to power a CPAP machine while you're out off grid where you're camping, or maybe a 12-volt refrigerator, keep your food and drinks cold while you're out on the trail. So stay tuned. Maybe this video can help you out on your build. Okay, so to explain a little bit as far as how these tests are going to be ran, all the tests are going to be off 10-foot lengths of wire. So 10 foot for positive, 10 foot for negative, or in this case, I'm going to also be supplementing in. We'll be running a 10-foot positive and having a 10-foot negative running across a piece of 1x1 square tubing to demonstrate if we're tying into the ground of our chassis and actually using the metal frame of our vehicles for a ground, and how that affects our voltage drop as well. So to start off, we've got a Victron smart shunt here. We're going to be reading the amperage load that's going to be applied to the circuit in that case. So we'll see the amperage load here. At the end of the 10-foot length, I've got a Victron smart battery sense that's going to be reading our voltage at the end of our wire and before any wiring for our load at the other end. So in some of these cases, we're going to be using this light bar and 2 fog light pods that's going to be creating an amperage draw at the end of this. I'll also be adding in the inverter, the small inverter here. And then I'm also going to plan to add in the 12-volt compressor style fridge that you saw to see at the end of a 10-foot length, could you even run that approximate 5 amp draw on that refrigerator, or is it going to go into a low voltage fault due to the voltage drop that takes place across that length of wire once that load is applied? So you should see this phone right here. That is reading at the battery smart sense, and I think it's going to read somewhere around 13.27, 2829, somewhere in there. And then at my smart shunt right now, I'm reading 13.29, and maybe you can see that. So it's between 28 and 29. So we're going to say that all these tests are starting off with the battery fully charged at reading a 13.28 volts right now. There shouldn't be much voltage or much amperage draw that should deplete that very much. So we'll just say that that's going to be the starting battery voltage for all the test. And then we'll document what the voltage drop is across this various different amperage loads and across the different wires. And so just to show you the wires we're going to be testing today, this is a 10 gauge, call it a solar wire. It's just wires for solar panels. It's the double insulated. This is a 10 gauge. It is a tinned copper. This is a 12 gauge, just a 3 conductor extension cord. That's just a copper stranded wire. This is a 14 gauge. This is tinned. This would be referred to as a marine style wire. It's kind of like a Romex, but it's actually a copper wire that's tinned. You can see the silver on that. And so that's one good option a lot of people use. This is one that will trick you. So this appears to be copper, if you can see that, but this is copper coated aluminum. It's referred to as CCA, and this is a 14 gauge 2 conductor wire. And this one tricked me earlier on in my build. So that's one that I want to show you. And then this is a 16 gauge, just extension cord wire. It's 3 conductor. And for this test and the 12 gauge, I just painted the end of the wire red to where I've got red and black consistent across all the testing. Okay, so first up is going to be this 18 gauge, 15 amp capacity wire. So just to show you, 18 gauge, 15 amp capacity. This was a 12 volt cigarette style extension wire a friend gave me. And as soon as I saw it, I knew that there was no way it could supply that much power. The conductors are super small on this, but I've got that wired in here. I'm going ahead and for all the tests, I'm going to connect into a set of bus bars to screw down to do a mechanical connection on these wires to not have a whole bunch of connectors being used on here. So I've got 2 of the pod lights to start off with. And so the voltage on this phone should have said somewhere around 13.27. And hopefully you're watching right now. It should show about 12.89 on that phone there. I've also got a cigarette style plug that I added into here. There's the Victron Smart Sense here, reading the voltage here at the end of the wire. And so I'm going to also be plugging in 12 volt style refrigerator so we can start to see the voltage drop take place on that as well. So right now you should be showing about 12.27. That's going to take a moment to start dropping down. But on this display, it's actually showing that by the time it gets into here and into its circuitry, it's already down to 10.9 volts. So once it starts increasing its amps and starts its cool down cycle, it is going to low voltage shut off would be my guess. I haven't checked it on this one just yet. So this did go into the low voltage shut off mode. In the interest of this video being as short as possible, I wasn't going to record that. The Victron Smart Shunt did show a total of 4.9 amps coming across this 18 gauge wire when this no longer could get the volts that it needed and completely shut its compressor off. So this is the exact reason why I want to make the videos, just so that people can understand when you have voltage drop across various wires, how it can negatively affect your installation of various different devices. Just the 2 pod lights themselves are pulling 1.6 amps or 21 watts. And with the Victron Smart Shunt, you can see that here. So 1.6 amps, 21 watts is coming off of that battery right now for these 2 LED style pod lights. So over here on the graph, how this is going to continue across there. So we've got the 18 gauge cigarette extension wire at the start of where these lights connect, where the battery smart sense is. It was reading a voltage of 13.27 volts before the load was applied. After the load was applied, it dropped down to 12.83 volts. And then this is the volt reading at 10 feet with, in this case, 1.6 amps applied. Once I applied the fridge to it, it could no longer do it. Okay, so the next wire up is going to be this 14 gauge CCA copper clad aluminum. And you can see right there through the middle of that wire, I actually took a razor knife to scrape off some of the coating of copper off of there. So the wire is actually going to appear to be copper, but if you actually look down the ends of it, you'd actually be able to see that it's aluminum on the inside. Okay, to try to speed things up just a little bit, I'm going to do some of this off camera. So with 2 pod lights, the LED light bar, I ran a 12 volt to 120 volt inverter, rather small inverter you saw earlier, running 2 LED shop style lights that run on 120 volt. So with the combination of those 5 lights combined, we've got 10.6 amps. At the end of the 10-foot wire, I'm reading at 11.23 volts with pulling the 10.6 amps. I then disconnected that and ran just this 12 volt refrigerator, which pulls around 2.2 amps. That 2.2 amps at the end of the 10-foot wire, I'm reading 12.52 volts. Now, at the end of that 10-foot wire, I've got about a 2-foot lead running to the cigarette plug. I then have the factory supplied power wire for this refrigerator. It's again a cigarette plug. It's about a 12-foot length of wire. And then I'm reading right now 11.6, 11.8 volts at this refrigerator itself. Now, a perfect example of how voltage drop takes effect. The battery is reading right now, showing about 13.6 volts at the smart shunt. We're reading, you should be able to see there, probably around 12.5 volts. Okay, so 12.75 volts at the end of the 10-foot wire. That fluctuates just a little bit. And then at the refrigerator, I'm reading 11.6, 11.7, 11.8 volts at the refrigerator. So we're dropping around 2 volts across, say, the 20 feet of wire combined that's running to this refrigerator, which could be a very good example of how you might run something in whatever your build is. Now, to give you a good example of how voltage drop is going to adversely affect you. So say I've ran my wires a little bit too long, a little bit too small, or less quality wires than I should have. Now I'm running a 14 gauge copper clad aluminum wire. So let's say I turn on a light. So we've got a pod light on now. Now at the battery sense right here should be reading about 12.6 volts. This is still about the same at 11.7. Let's turn it on another light. So there's the LED light bar. You probably couldn't hear, but I heard this thing considerably drop down as far as the fan and the compressor running. It's now 10.9, 10.6 volts, 10.9. SmartSense is reading 11.93, and the shunt is reading at 12.8. So it's still currently running 11.0 volts. Let's go ahead and turn on another light, see what happens. So there's that other light. It just cut off. And now you see F1, which is a low voltage shutoff. So without having the right type of wire gauge supplying the power to these devices, a weekend of camping or, somewhere out at the park or whatever, you're trying to figure out why your refrigerator is not running. Just running a couple devices, maybe a radio, maybe a couple lights. All this stuff should be working great. It worked right when I tested everything, but now it's not working. So that's a perfect example. This copper clad aluminum wire, don't use it in your build. Okay, so I've got it switched out to the 14 gauge. This is a copper wire. It's referred to as a marine wire. So it's got this outer insulation plus the inner insulation. It is a tinned wire, Tinned. You'll be able to find this on Amazon and just about any length that you would want. This is a very good option for a lot of various loads on your systems. You can buy this by the roll of, 20 feet, 50 feet, 100 feet, whatever. You can get this off of Amazon. I think this 100-foot roll might have been $20 to $30. So we've got a 10-foot length of that on the 2 single pod lights. Earlier when I did this was at 13.08 with the 2 plus the light bar as we've got it now. I think you're reading 12.69. Earlier I was reading at 12.78. And then I also hooked up the inverter with the 2 shop lights at the 10.6 amps pulling through this wire. I was still reading at 12.19 volts. I also, just a moment ago, disconnected the inverter. The 2 lights plus the refrigerator, I was reading at 12.47 volts with both of those running. Now that's going to be about 7.5 to 8 amps for all of that running, but this was running completely fine, and it was maintaining at this point at about 12.5 volts, 12.47. Right now at the refrigerator, it's showing 11.1 volts, 11.2 volts. It probably will climb back up just a hair more, 11.3 volts. And so this is about as much as you want to try and run on, again, this is nearly probably 22 feet of wire at that point of that refrigerator. Okay, I've got it switched out to a 10 gauge, what I'm going to refer to as a solar wire. This is designed for exterior installations for running solar panels. So it's 10 gauge. It is a copper stranded tinned wire, and it's double insulated on each one of these. So we've got 2 separate conductors here. Double insulated, makes it a little bit stiffer. Still nice to be able to wrap around corners if you need to. So we've got a 10-foot length of that. I also went ahead and hooked up the inverter for you to see this here. So you should be showing 12.8 volts there. Earlier with the 3 lights on, I'd recorded 12.85 with just the 2 small pod lights, 1304. Now, an interesting result I got just a moment ago, and if you're a bigger electrical nerd than me, I'd love for you to kind of tell me why this is or validate my thinking on it in the comments. But earlier when I turned on the inverter with the lights, I was reading 10.6 amps on some of these lesser sized wires. When I turn it on now, I was reading nearly 11.6 amps. So right now it's working on kind of stabilizing out. Yeah, so I'm reading 11.62 amps right now. If you can tell me why that is, I'd be really interested to know. My thinking would be is where we've got more resistance, lesser flow of the electrons through the wire or whatever the case may be. My belief would be is that there's not as much availability for the amperage to go down the wire. And so with the bigger conductor, that's how with the same loads, I'm actually sending more amps and I'm sending more volts down the line, maybe more unrestricted. So if you know that answer, put that in the comments. I'd be really interested to know that. Are you confused yet? Do I have your attention still? Okay, so let's say you don't have a crazy build you're looking to do. You want to be a lot simpler. Say you're going to have a fuse block. You're going to run one set of wires to a couple lights, smaller lights, LED style lights, not pulling a whole bunch of power. You're going to run one set of wires off that fuse block on its own fuse over to your refrigerator. You're going to run a set of wires off that fuse block over to a diesel heater, and you're trying to keep things simple. Well, if you're confused by the 10 gauge wire, the 12 gauge, the 14 gauge, the 16 gauge, the 18 gauge, the oxygen free copper, the stranded copper, the tinned copper, the copper clad aluminum, the CCA, why was I wearing those glasses anyways? If that type of stuff confuses you, then fair enough. One potentially simpler option you could do, extension cords may be an option that you could entertain. I'm not going to say it's your best option. It's a little bit thicker in physical size because you've got a third conductor and you've got a nice heavy duty insulation on there. That's not a bad thing, but trying to hide something that big in your walls or your build or whatever may be a little bit tougher. But generally, here's the asterisk over to the side. Generally, the wire inside general extension cords is going to be a pretty good quality. Now, if it looks like something you're going to plug your grandmother's lamp into, just go ahead and start off by throwing that one away. There's generally, these are not a different color from one side to the other. One side is grooved where one side is smooth, and you can tell what side is what. But for the most part, that's a thinner gauge wire. You don't want to try and use that because you're going to be back down into this range here where the wire might be pretty good, but it's just flat out too small for most things. So we're going to just disregard that completely for this topic. But say you've got an extension cord, this is a 16 gauge extension cord. This is going to be often referred to as a light duty or maybe up to a medium duty extension cord. You're going to have 3 conductors. You're going to have that middle prong on each end. Maybe you've got a bunch of these laying around that the end's ripped off, a prong's broken off, maybe it's been cut in half and you haven't used it as an extension cord. You haven't repaired it as an extension cord. But if the wire is still in good shape, that might be a good option to use. If there's a whole bunch of damage to the outer insulation, if it's been maybe damaged and wet, then there could be corrosion in there. Throw that away. Don't add that resistance into your build. Okay, and depending on how closely you're following along with the numbers on that phone there and the numbers across this board, it's been several days since I did this first half of the video. I charged the battery back up because it was, I think, about 5 or 6 hundredths of a volt lower than when it had initially started. I went ahead and topped that off. So these across this line here was recorded prior to charging it. So all of this is basically going to be the same, but going forward, I'm going to be marking the volts with a red marker as they're about 0.06 or 0.07 volts higher now than what they were before. But on the 2 pod lights, I had 1307. On the 3 lights together, I had 12.69. With the 3 lights here, plus the inverter running on the 2 LED lights there, I was recording at 11.3 amps and 11.92 volts. Just the fridge, had no problem running at all on that. And I was at 12.97. And then the fridge plus the the 3 lights here, I was at 12.39. So again, as the volts was somewhere around 13.2 volts when I was doing all those testing. And except for when we got into the 11.3 range, we had very minimal voltage loss across the 10-foot length of wire on there. So the 16 gauge wire would have a pretty good lack of voltage loss for some smallish type loads that you're going to have on your type of build. Okay, so I've got the fridge running along with the 3 lights over here. You should be seeing close to 12.80 on the phone over there. That's good voltage for the distance that that fridge is running. If I disconnect off the 3 pod lights, then you should be reading 13.08. A moment ago I did this, it was 13.09. That's great voltage for the standalone fridge by itself. It'd never be power hungry if it's getting 13 volts. So that's a great option. Now, one personal testament of when I've used this type of wire for my own type of build, this is actually about a 75-foot extension cord, or what's remaining of 100-foot rather, but I cut off about 75 feet of it, and I put SAE cables, connectors at the end of both ends. And we actually use this for camping with my son, where we had the Axiom with our power system in there. It was wintertime camping. May have been snow on the ground, but I don't remember exactly. But it was very cold, I think in the mid-20s at that time. And we were camping in the Axiom. My son was tent camping on the other side of the campsite, and we didn't have this additional battery, which we got for him doing off-grid camping. So we actually connected this to the Axiom trailer and ran an extension cord 75 feet away to run his diesel heater, and we camped the weekend running that way. I do hope this video has been helpful to you. Hopefully this helps you to be able to know what to do or what not to do. And if you want to see some more videos like this, like and subscribe.